Hello, let's have a look at a question which is to do with derivatives from the graph. So we've got a function here and split up it as a compound fraction. We've got a function when x is less than 0. That's this orange part of the curve here, from here to here. And then we've got a function when between 0 and 1, so we've got a different function. From 0 up to 1, and that includes 0. And we've got a function from 1 to 2, which is this part of the graph. And we've got a function from 2 and onwards when x is greater than 2. That's that part of the graph. So we've got the orange, the pink, the green, and the blue. So we've got here, determine the derivative of the function when x is less than 0. So we're dealing with the orange part of the graph. So the derivative of x squared minus 1 is 2x. Okay. Determine part B, determine the derivative f dash x for when x is greater than 0 and less than 1. Okay, there's a mistake there. Greater than 0, 1, and less than 0. Okay, so between 0 and 1. So that's in here. That's the pink part of the graph. So we're talking about between 0 and 1. And if the function is 1, if the function of x is 1, then f dash x, the derivative of 1, is a 0, because there's no x's, 1x to the power of 0. And so the derivative is 0. You can see on the graph it's a horizontal line, the gradient is 0. You can see that by just looking here, the gradient is 0. Determine the derivative for when x is greater than 1 and less than 2. So we're now in the green part of the graph. So between 1 and 2, greater than 1 and less than 2, the function of x is simply x. So the derivative of x is, that's 1x, is equal to 1. All right, so the derivative is equal to 1 between 1 and 0. And I think there's another part D, determine f dash x for when x is greater than 2. Now we're into the blue part of the graph, and you can see that that the function is 2 root x plus 1. So the function of x is 2 root x plus 1. I'm just going to change that into 2x plus 1 to the power of a half. So the derivative is a half times 2, which is 1. And that goes down 1 to a negative a half, which is, that's fine. Okay, that's fine. It's the square root of, if you wanted it as a fraction, it would look like this. But that's fine. State the value of x for which the derivative is not defined. Okay, let's look at the graph. Where is the derivative not defined? Let's have a look at the graph. Okay, you can see it's smooth, and here there's a bend. All right, let's just, there you can see there's a bend, and here there is no value for x. So when x is 1 and when x is 2, the derivative is not defined. So we'll just say values of x when x is 1. Justify your answer. There is a bend, not a bed, bend, B-E-N-D, in the curve, i.e. it is not smooth. It is not smooth. And when it's not smooth, you don't get a natural flow of derivatives. You can't have the same two different derivatives at the one point if it's a bend at that point, there's no gradient to the curve. So the other one is when x is 2, simply because there is no function value at x equals 2, because it's not part of the domain. X equals 2 is not defined, or the function of 2 is not defined. The function of x when x is 2 is not defined. All right. I hope this has helped. Stay happy.